So here's the crazy part. Netflix routes over 2 billion API requests every single day. 2 billion! That's more than some entire countries see in internet traffic.
2 billion? Wow. Okay, that's a lot. But how do they even manage that? I mean, just the sheer scale of it sounds insane.
Exactly. And the secret weapon behind that scale is the API gateway pattern. It's not just about handling traffic, it's about making the whole system resilient, secure, and, frankly, manageable.
Okay, so paint the picture for me. What happens if they didn't have an API gateway? What's the worst case scenario?
Think total chaos. Imagine every single client, your phone, your smart TV, your browser, directly hitting dozens, maybe hundreds of different microservices. Each service has its own authentication, its own rate limiting, its own way of handling errors. Whew, it would be a distributed systems nightmare.
Right. So the API gateway is like a traffic cop, directing and managing all that incoming traffic and preventing total anarchy.
Precisely. Think of it like the front door to a massive hotel. The API gateway is the concierge, the security, the information desk, and the bellhop all rolled into one. It handles all the initial requests, figures out where they need to go, and makes sure everything runs smoothly.
Okay, I get the analogy. So let's dive into the core of it. What are the key benefits that an API gateway provides? Let's start with the most obvious.
First, decoupling. This is huge. The API gateway shields the internal microservice architecture from the outside world. Clients only interact with the gateway, not the individual services. This means you can change your internal services without breaking the client experience. Imagine rearranging rooms in that hotel. The guests at the front desk don't need to know.
Okay, that makes sense. But doesn't that decoupling add another layer of complexity? Now you have to manage the API gateway and the microservices.
It does add complexity, but it's organized complexity. It centralizes concerns that would otherwise be scattered across all your services. Think of it as moving all the wiring in a house to a single circuit breaker panel. More wires in one place, sure, but much easier to manage and troubleshoot.
Fair enough. So decoupling is one benefit. What's another?
Security. The API gateway is the perfect place to enforce authentication, authorization, and rate limiting. You can implement things like OAuth, JWT validation, and IP whitelisting in one central location. No need to duplicate that logic across every single microservice.
So it's like a security checkpoint at the hotel entrance, verifying IDs and making sure no unauthorized personnel get in.
Exactly. And speaking of security, look at what Cloudflare does. They essentially provide an API gateway as a service, handling DDoS protection, bot mitigation, and all sorts of security features before traffic even hits your servers. That's a massive win.
That's a great example. So we've got decoupling and security. What's the third major benefit?
Performance optimization. The API gateway can aggregate multiple backend requests into a single client request, reducing network overhead. It can also cache responses, compress data, and transform protocols to optimize performance for different clients.
Ah, so it's like pre-packing your suitcase with only the essentials, rather than lugging around your entire wardrobe.
Precisely. And here's where it gets really interesting. Think about Netflix again. They use the API gateway to tailor the experience to different devices. A smart TV has different bandwidth and processing power than a mobile phone. The API gateway can optimize the data stream for each device, ensuring a smooth viewing experience.
Okay, that makes a lot of sense. But what about the downsides? What are the trade-offs of using an API gateway? There has to be a catch.
The biggest one is increased latency. Every request has to go through the gateway, which adds an extra hop. This can be a significant problem if your gateway is poorly designed or overloaded. It becomes a single point of failure and a potential bottleneck.
So it's like having a really slow concierge at that hotel. Everyone's stuck waiting in line, even if their request is simple.
Exactly. And that's why careful design and monitoring are crucial. You need to make sure your API gateway is highly available, scalable, and performant. Companies like Uber use multiple API gateways, strategically placed in different regions to minimize latency and improve resilience.
Multiple gateways? That sounds even more complex.
It is, but it's a necessary complexity at that scale. It's like having multiple entrances to the hotel, each optimized for different types of guests and traffic. Think about ride requests during rush hour versus a late-night airport pickup. Different demands, different gateway configurations.
Okay, so latency is a major concern. What else should engineers be aware of when implementing an API gateway?
Another common pitfall is overloading the gateway with too much logic. The API gateway should focus on routing, authentication, and basic transformations. Avoid putting complex business logic in the gateway itself. That belongs in the microservices.
So don't turn the concierge into a personal assistant who handles every single request imaginable. Keep it focused.
Exactly. And think of the API gateway as a thin layer that sits in front of your microservices, not a monolithic application itself. Amazon, for example, uses a very lightweight API gateway service, focusing on core routing and security functions while pushing the heavy lifting to their back-end services.
That makes sense. Keep the gateway lean and mean. So we've talked about the benefits, the trade-offs, and some common pitfalls. What's the one thing that most engineers get wrong when implementing an API gateway?
They treat it as an afterthought. They build their microservices first and then bolt on an API gateway as an afterthought. That's a recipe for disaster. The API gateway should be designed in conjunction with your microservice architecture, not as an add-on.
So it's like designing the hotel lobby before you build the rooms, not as an afterthought. The lobby needs to be designed to handle the flow of traffic and the needs of the guests.
Precisely. And here's the counterintuitive insight. A well-designed API gateway can actually simplify your microservice architecture in the long run. By centralizing common concerns, it allows your individual services to focus on what they do best.
Okay, that's a good point. Focus on core competencies. So what are some practical takeaways for our listeners? What should a software engineer do differently after listening to this?
First, start small. Don't try to build a massive, all-encompassing API gateway from day one. Begin with a simple routing and authentication layer and gradually add more features as needed. Iterate and learn.
Okay, so crawl, walk, run. Makes sense. What's another actionable takeaway?
Monitor everything. Latency, error rates, traffic patterns. You need to have a deep understanding of how your API gateway is performing. Use metrics and dashboards to identify bottlenecks and optimize performance.
So install security cameras and track everything that happens in the hotel lobby.
Exactly. And finally, choose the right tool for the job. There are many API gateway solutions available, both open source and commercial. Evaluate your needs carefully and choose a solution that fits your specific requirements. Don't just grab the shiniest new toy.
So don't just pick the fanciest concierge system, choose one that actually meets the needs of your hotel and your guests.
Precisely. And remember, an API gateway is not a silver bullet. It's a powerful tool, but it requires careful planning, design, and maintenance.
True. And if you don't architect it well, you might just end up with a gilded cage.
Exactly. 2 billion requests a day? That's not magic, it's architecture.